Hello, and welcome to the videos for section 6.8, graphing the trig functions. So we're going to talk about the graphs of sine and cosine, the ones we have laws for. You may be thinking to yourself, wait a minute, didn't we already do this? Are you talking about the unit circle? Essentially, yes, we're going back to the unit circle, but we're going to do something pretty cool with it. So here I have the unit circle, right? If just a little throwback in case you forgot, we have a circle made of one unit, hence its name unit circle, right? And what we were doing is we would take this and we would find 30 degrees, 60 degrees, 90 degrees, I'm recording, and then to 70 degrees, and we'd find all of the trig functions for that, sine, cosine, and tangent, right? And we did the inverse ones as well. But what happens when you take all of those values and you don't look at them individually, but look at them at the same time? What we're going to do is basically graph all the sine values throughout the circle. Okay, so if you notice on this x-axis, we have uncurled our circle. Here's 0 degrees, here's the 90 degrees, here's the 180 degrees, here's the 270 degrees, and here's the 360 degrees. And then we go back and we can do it again. This would be another 90 degrees, right? Or 360 plus 90 degrees, which would be 450 degrees, okay? So we just keep going. This is as the degrees get bigger. What happens? Well, let's take a look at it. We're going to watch the triangles appear. Remember, we've done this with a slider before. We're going to have the triangles going up and then flip over and then back around again. But watch what happens as you find those values. They go up to 1 and then back down to 1 and then back up to 0 and going back. It goes back, but that's fine. So basically what happens is as this circle turns around, you get this sine wave. This is called a sine wave. If you were to keep going, this wave would repeat itself, and we call that periodic motion, just to throw back to some physics classes, right? But this is the curve that you see. This is as a function of time. Now, the first half of the year, we've dealt a lot with functions, right? So this is a sine function. This is one in which we have this behaving as a function of time. Sorry, my screen stopped displaying. There we go. So now we're back on the notes, right? And we see the sine function. We see that periodic motion. And notice the dot line is going to happen again and again. This from 0 to 360 degrees, that's what we call one period. We're going to talk about that as well a little bit more. So let's reset this whole thing now. And look what happens when we track the cosine functions. Instead of tracking the y's, let's track the x's. What happens there? You see that same movement, that wave-like movement, except this time the wave's going to start up at 1, go back down to 0, down to -1, and then back up to 0 and up to 1. Now again, this is periodic motion. So again, it's going to keep going down and up, down and up, down and up. But that's what it's going to look like, and we get another wave, okay? We get a very similar wave. All right, let's go ahead and pause on that. And just in case you're curious, here's what happens with tangent. Tangent's super fun. It ends up flipping out. So this one we're not going to talk about a lot. This is more of an honors concept, but I just thought it'd be fun to look at. Remember how sometimes tangent did not exist? These are the asymptotes of that does not exist. These are the places where they don't exist, so it gets really, really close, and then it flips over, and it's super fun to look at this. But if this is not one we'll be covering, I just thought I'd show you in case you wanted to check it out. All right. So let's go look at the two we are going to look at now. We're looking at sine and cosine. We're going to graph them ourselves together. All right, these are some examples in case if you wanted to look at those, but we're going to jump down here. Now, there are some pieces to this function. These pieces we've already talked about in previous chapters, things like our transformation chapter. Let's start with the period. We have y equals sine x. Now, we just talked about this. One period on the sine is going to stand for how many times do you have one wave? How long does it take to get one wave of the function? Because it's going to keep repeating itself. In a standard, regular old sine, that would be 360 degrees, or more commonly, 2 pi. Okay, so we're going to have 2 pi for this wave. The amplitude is how far up and down it goes. On just a basic sine function, it's only going to go the unit circle length, or 1. It's going to go up 1 and down 1, up 1 and down 1, up 1 and down 1. The midline, you guessed it, that's the middle line. Where is the wave centered? In the regular old sine, it's going to be around 0. We would actually write that as the line it's centered around, y equals 0, right? Because that's where it would be centered, around y equals 0. And then the frequency is how many periods do you get how many waves do you get per period? So 1 wave per 2 pi or 1 over 2 pi. Okay, so 1 wave per 2 pi. Does this one have a shift either vertically or horizontally? No, it does not. And we will show you a lot that do, but we'll get there when we get there. So let's go ahead and plot this information now. Now I know this amplitude, let's start with the midline. Midline I've already drawn. I'm going to draw it a little better. This is my center point, y equals 0. Good place to start, right? Good place to start at the center. It's going to go up and down 1. So the biggest it's going to go up is 1. Left this axis unlabeled intentionally so that way we can maybe give ourselves a little more room between 1 and -1. And then it's going to go all the way to 2 pi by the time it does that. In order for me to graph this correctly, I kind of have to think in fourths, right? What is it going to be at 0? It's going to be at 0 degrees. What is it going to be at 90 degrees? It's going to be 1. What's it going to be at pi? It's going to go back to 0. What's it going to be at 270? It's going to go down to -1. And what is it going to be at when it goes back to 0? It's going to go back to 0. And so now that I've kind of thought in fourths, I can connect the dots to the best of my ability. Now, I am not a computer, so obviously things like this are going to happen. On the computer, you shouldn't have to worry about that, right? But when you're graphing them by hand, it's incredibly hard to get that wave perfect. Don't stress yourself out about it. Notice what I did there. I implied that this does not stop at 2 pi. It's going to keep going and keep waving over and over and over again, okay? So don't do a hard cutoff if you can help it. Again, on the computer, it doesn't really matter. And now we have graphed the sine function. Cool. Let's go do it again with the wave, or with the cosine function. Regular old cosine function. Again, it's going to go 1 unit circle, so it's going to go a period of 2 pi. Amplitude, again, it's only going to stretch the unit circle, so the amplitude is also going to be 1. It's going to center around 0, and again, 1 cycle per 2 pi. And again, no shift up and down, because it's boring old cosine. Now, if all that information is the same, how do I know where it starts, right? How is this one any different? Well, it's different because what is cosine of 0? Cosine of 0 degrees is actually 0, 1. It's 1, 0, right? So if this is our 1, and here's our -1, remember that on the unit circle, when we found cosine 0, that equals 1. And so this one is going to start up at 1. It's going to head down at 90, it becomes 0. At pi, it becomes -1. At 270, it becomes 0 again. And then at 2 pi, it becomes 1 again. And so now, nope, I actually do want that. We're going to try our best to get that. Oh, nope, failed. Now, it's not a V, okay? It's very important that you show the audience that this is not a V. It is a curve, right? It curves down and curves back up, and it curves back down again. And even that's a little bit inaccurate because the curve here should stop right at that dot, but it's fine. Again, I am human. It is a curve going down. So if you want it's like a cursive V, that's fine. You can remember it as the cursive V. Just don't confuse it with the absolute value function, which is a hard V, right? The absolute value function looks like that. That's not what we have going on here. This is a wave-like motion. It's basically the sine one, just shifted over, okay? All right, cool. So those are your 2 basic functions. Now we're going to take those and we're going to mess with them, okay? We're going to mess with those guys and we're going to shift them left and right, up and down. We're going to stretch them out. We're going to do the same exact thing we've done with any other function. These are our 2 new parent functions. Okay, so these are our parent functions now, and we're going to go look at what happens when you throw 2s and 3s and pi over 2s in there and what happens, okay? And I'm going to show you that in the next video.